down too much, then you can apply some filters, typically distance filter factors and so on. I will jump a few slides now because we will handle that at the end of the wrapper presentation. And go to 5900. So as you saw, the Pro and the Rex, they have more or less the same software, but some functionality when it comes to your interface for the Rex is lacking. We don't have that. Okay, now you can see what the difference is when it comes to the 5900. I mean, you remember the FFT and the SIL and so on, right? This is the block diagram of complete headgear. What is inside to the antenna? This is what it looks like inside. We have our tank bus, 2-pair cable, connected to the terminal block, and this is then connected to our communication module to distribute the power and the communication also. And the power is distributed to the different boards, and the communication is also existing between the different boards here. So we have a communication module, a processor module, and a radar module. So you can say that we have 3 different boards inside, molded together in one nice package. You cannot remove any CM or PM or RM. You can just remove the complete package. You cannot, like a Rex gauge, remove the SPC card and so on. That is not possible with the 5900. It's just a complete package. So here we have the radar module, and that radar module is of course connected mechanically to the antenna. If you have a 2-in-1, which is a patented new thing in the 5900, you have 2 exact identical modules. Both modules will be connected to the same antenna. Have you opened up the 5900 to have a look inside? Yeah. So you see, we have also this SIL functionality. It means that we have one direct link out, and you connect the cable from the gauge to the hub. This yellow line here, this is the SIL cable. See, this is yellow, that is yellow. So it's a direct line, and it's just hardwired directly to the radar module. And that's the SIL. So when we say that we have, if you have a SIL 3 gauge, like we have on the table, which I'll make a demonstration later on, when we say that we have a 2-in-1 gauge, it's not quite true. Because we have actually 4 gauges in one. We have 4 gauges. Because this complete module and the level you get out here, that's one radar. The second radar is this one. So that is also a radar. When you do a configuration of SIL gauge, we say we have SIL 2, it means require only one. We call it 1-in-1, 2-in-1. So 1-in-1, we have 2 gauges. First you configure normally by installing the device in Clean Setup. And then, when you've done that, you go to the safety alarm configuration. That configuration is only done here. You have actually 2 radars you have to configure. So this button you push where it says safety alarm, then you go into this one and do the configuration. Because when you do the normal configuration, you say that, okay, I have this antenna, that is the reference height, blah, 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 and the type of tank and so on. You do it here. Safety alarm, you have to do the same thing there also. But it's more primitive. It's like the old, you can go TRL2, or the very first. It's numbered only. It's no tank scan, nothing. So it's here. It's only numbers, you have to enter. So then you do the safety configuration in the radar module also. And then this is then keeping track of overfitting. If the level comes to your set point, immediately it will trigger this one. And then you have an alarm out from the pump. So this is what you're doing when you do a new safety configuration. So this here have nothing to do with this. This is totally bypassed, they're totally separate. And if this says, if you configure it wrong, that the alarm has triggered, then the relay with SIL will also. You've seen this before? We have a boot application.
Yeah.
But we have boot in RM and PM. So it means we have boot and application. And we have boot and application here also. This afternoon, when I present you the SIL configuration, I maybe take the theoretical part a little bit quick on the SIL configuration, because that is just showing you exactly what you have to do and to configure SIL. Because I will do a practical demonstration of the SIL also. But since we have only one SIL gauge, the idea was first that you try it on the lab group, but we couldn't get 5 pieces of SIL gauges. So I decided I will connect my laptop and do a live session, right? Then I had a small idea that if we have time after this demonstration, I will take a small portion and tell you what the SIL is all about. Make another presentation which will actually tell you about the SIL itself. Not how we configure our gauge, but SIL in general, if that is okay, if you feel that is interesting. Yeah. But we'll check that after with the demo here. Okay? Okay, back to this one. So it means we have a boot and application software here also. So our safety. Yes.
Earlier slide.
5900, how many times do you go? This one file contains boot application. So it contains all 4 files.
But the program will be tied with the SIL.
It's related. The software in this one, because it's related to the SIL, every time when we have this gauge SIL certified, there is a second authority which approved this. The company name is Exida. They have come to us, they have done everything with the check how our boot work, everything. It's a big job to get this gauge from design approved for SIL 3. Very big job. It means we have pressure from this company every time we make hardware change related to this part. We must do a theoretical analysis. Okay, what will be the risk with this one? And we have to send papers, and they have to look and say, okay, you're still SIL 3. Also software. Yeah. So if we change software here, we find, oh, there is some problem here, but only here. Only this portion is related to the safety. If we make any changes on the boot and application here, we also must go to this Exida company and say that, please look, which make the change, is it okay? And if they say okay, it's okay. So you can imagine it takes a long, long time if we make just one change in the SIL area. So we don't want to start. That's why we have separated the normal application and for our normal application, because that is has nothing to do with the SIL one. So this software we can improve, upgrade, and so on. So if you look at the software versions in the radar module and the processor module, they will be different. So the radar module software will stay the same rules, same application, so that because we don't want to do anything with the SIL because it costs a lot of money. So that stays the same, but the PM, this can continue, have different versions, but this RM stay same version, because it's all related to SIL. So if we must do it, it will be a big procedure to change SIL software. But it's still only one file we send you if you want to upgrade. So in that case, it will just look and compare, do we have to upgrade RM or not? If not, we just upgrade that portion. That's how it works. So we have application and move in both places.
No, I have this PDF.
Same as Rex and so on. I know Elan. There's a lot of questions from these guys, they're very good. Still the same, it's slightly different. We don't have to check all the hardware because we don't have temperature input, anything like that, so it goes in quicker. But it's the same, generate FMCW speed and other things like that. What I want to come is to this signal processing tool so you can see what it looks like. And after that, we'll take it. So the PM is doing the basic signal processing. Also measurement log needs, you have thresholds, C4 thresholds, type corrections, level rate calculations, and so on. LPG, gas type correction, other things like that. Volume calculation, just a raw type. You have tank geometry, shape, bottom type. Also managing the parameter data. So no difference from Rex Pro. Here comes our signal processing. And as you see here, this is a little bit different. Suddenly you have this radar module that's separated from the processor module because they are two different cards. But it's still the same. The only thing here is that when this is not transmitting, it's more or less going into idle. So to save energy, it stops. And then when this is then requesting level, so it will send a command and tell this one, please give me a signal. And then it will, and then send back the signal. When we have a SIL gauge, then also this gauge will take the same signal and make a node processing and check, do I have a high level up triggered or not? If not, nothing. But if you have a high alarm situation, then this will immediately take the SIL alarm to the hub and say, please activate it. So this is how it works. So this is commanding the radar module to make a sweep. And then this will send back the sweep. And then you have the normal procedure here with the fast filter and level and so on. So that is the difference. Yes. No, it's because PM needs to give the normal level, the normal level to the operators and see what it is. But if you bought the SIL gauge, then you also activated the SIL relay and the functionality. And then, because when this is commanding a sweep, this is doing sweep and sending the sweep to the PM, but it's also making its own calculation in but only when you have a SIL activated. Otherwise, it will be command from PM, make a sweep, and send back the sweep, nothing.
How do you say to send the energy? I will pick up the energy level.
Yeah.
But if the level will go up and down, go up, reach to the upper level.
Then the PM
But-
we can stay.
Yeah, but we are talking about very short periods of let's say, going down a little bit. What he's doing is more or less changing, I mean, lower frequencies of the processor or something like that. So it's going a bit slower, and then when it's time, it's rushing and doing the sweep, and then it's going back. And then it's running, doing things like that. So that's what makes sense. Okay, antenna selection. I think that all these pictures you can see in the configuration, so there's nothing strange. One thing I want to mention is that when you have pipe measurements, when you select a pipe antenna, it's very, very important to have very, very exact diameter and the inner diameter of the pipe. Because if you don't have that, based on the in diameter that we put, we adjust or compensate for the speed inside the pipe. And this way we get correct level. But if you have one pipe with 200 millimeter diameter inside, and you say it's 216, it means the gauge says, okay, it's 216, but in reality it's 200. So then the gauge will, when you make a hand calibration, at this point where you make the calibration, it will be good because you calibrate. But when the level goes up and down, then you have a positive or negative arrow above and below because the pipe diameter is correct. So that is important. Make sure the pipe diameter is very, very accurately double checking. Not just if you say it's 8-inch pipe, okay, 8 inches is 8, okay, 230. Doesn't work like that. It should be done accurately. Okay, usually define antennas and things like that. Just quickly about this filtering, what's happening, and then we go forward. Level filtering. So the distance filter factor, when you have a value of 1, it means we have no filtering on the level. So it means that if this blue line, if the level goes from that point, is the actual happening, then when you apply filtering, then the percentage value is the red line. So if you have an unstable surface like this is what's happening in the tank, and you have then the red line here representing the percentage as you as an operator see. When you increase, or well, decrease the value actually, 1 no filtering and 0.005 max filtering. It attenuates, dampen the signal max. Then the response will look like this. So this is the actual happening, and this is the response. So it means that this level is much, much smoother. So that's what happens. Okay. Good. Questions? Anyway, when you get the presentations, you can have a look at the facilities later on. Now, Elan, time for lunch, right?
Yeah.
Okay, very
So
good.
if you are done.